Complex fractions. A complex fraction has a fraction in the numerator and or in the denominator. So it has fraction in a fraction. We are going to simplify complex fractions. We're going to look at two methods. The first method that I'm going to show you will only work if you have just a single fraction on the numerator and a single fraction on the denominator. So it doesn't work all the time, but it's a simple method. It is just to write it across instead of vertically as division. So 2/3 divided by 5/6, and then I think you would probably realize what to do. You change it to multiplication and invert the divisor. You can simplify on diagonals. So we can divide by 3. 3 will go into 3 once, into 6 2 times. Nothing the other direction on the diagonal, and then multiply across. 2 times 2 is 4. 1 times 5 is 5. And now that is simplified. This complex fraction also has a single expression in the numerator and in the denominator. So we can use our first method. We will write it across. As division. Change it to multiplication and invert the divisor. So your first fraction stays the same. This changes to times. Second fraction inverts. You will simplify on your diagonals. We can divide out the 3. 3 will go into 3 one time. 3 will go into 12 4 times. You can take out your x's that way if you want. They match up. And on the other diagonal, we could take off one of the y's. If you don't want to take your y's off here, you can do it over in the answer when you reduce. Multiplying across the numerator, we have 1 times 7 is 7. And y times 4, 4y. Our next problem also has a single expression in the numerator and in the denominator. So we can use method 1, which is to write it across as a division. Change it to multiplication and invert the divisor. So first fraction stays the same. Changes to multiplication and the divisor flips over. Right, we can look and see what might cancel on our diagonals. On this diagonal, nothing cancels. On the other diagonal, nothing cancels. Remember, you can't take a piece off of this x plus y. It would have to be the entire piece. So we'll multiply across the numerator. We have negative 8 x cubed. Those exponents add. And we have y times x plus y. It's fine to leave it in the factored form. You don't actually have to multiply it out. This problem also has a single expression in the numerator and in the denominator. So we can use method 1. We write it across as a division. So 5 over x minus 2 divided by 7 over x minus 2. Change it to multiplication and invert the divisor. So keep your first fraction. Change to multiply. This one flips. And then we can simplify on the diagonals. This time we can take out that x minus 2. The entire piece matches. And then we will multiply across. We have 5 on the numerator, so 5 times 1 is 5. And 1 times 7 is 7 on the denominator. Nothing else we can do. Next, we'll look at our second method. This method would actually work for every problem if you chose to use it. The first thing you do is find the LCD of all the fractions. So we have 3, 2, and 4. We want the smallest thing that they will all go into. You can use primes or you can use multiples. So our LCD is going to be 12. We're going to multiply on the top by 12 and on the bottom by 12. What I find to be very useful is to actually write the 12 beside each piece. I wanted to show you first this way so that you can see I'm really multiplying by a form of 1. If I do 12 to the numerator, 12 to the denominator, 12 over 12 is 1. So it's okay to do. It just makes it a little easier if you actually put the 12 beside each piece. So I'm just going to rewrite and show you that. So what I'm really doing is distributing the 12. Put it beside every piece and then clean up. Your denominators should all cancel, otherwise you did something wrong. Right, so on the first one, this is 12 over 1. So 3 will go into 12 4 times. 4 times 2 is 8. In the denominator, 2 will go into 12 6 times. 6 times 1 is 6. 4 will go into 12 3 times. 3 times 1 is 3. And then we can finish on that denominator. 6 plus 3 is 9, and this will not reduce. For our next complex fraction, we will first find the LCD. Again, we have denominators of 4, 2, and 3. So our LCD is going to be 12, smallest thing they all divide into. So I'm really doing 12 times the numerator, 12 times the denominator. I'm going to go ahead and just write it beside each piece. And then clean up. In the first fraction, my 4 will go into 12 3 times. 3 times 3 is 9. The second one, 2 will go into 12 6 times. 6 times 1 is 6. On the denominator, 3 will go into 12 4 times. 4 times 2 is 8. And 2 will go into 12 6 times. 1 times 6 is 6. We'll simplify. 9 minus 6 is 3. 8 plus 6 is 14. And that will not reduce. For this complex fraction, our denominators are x and 5x. We have to cover every type of factor that's there, so we will need an x to cover those, and we will need a 5 to cover the numbers. So our LCD is 5x. We need to multiply that by every single term, whether there is a fraction or not. So we're going to do a 5x here. Here. Then we will clean up. On our first term, we actually will just multiply there. 5x times 5 is 25x. On the fraction, that x will cancel. So we have minus 40 over. On the denominator, 5x times x is 5x squared. And the second term, we can divide out the 5x. So we get a plus 3. We could look to see if we could factor to cancel anything out. In the numerator, we could take out a 5 as a GCF. That would leave 5x minus 8. The denominator, there's nothing you can do. So it doesn't reduce. You're not allowed to take out this 5 because the denominator has a plus in between the terms. It all has to stay together. So even though we had to do this thought process, since it would not reduce, the first answer is also correct. Either answer would be fine. For our next complex fraction, we have all x's in the denominator. You have to go with the highest exponent. So for our LCD, we're going to need x cubed. So we will multiply that by each term. Then we will simplify. On the first fraction, The x will go in there. One of them cancels off. So it leaves us an x squared. X squared times 7 is 7x squared. In the second one, 2 of those x's will cross off. So that will leave 1x. So we have minus 14x. On the denominator, the 1x will cross off, and that will leave 2 x's. So x squared times 1 is x squared. And on the fourth fraction, all 3 x's cross off. Right, we need to see if this will factor to reduce. On the numerator, we can take out a GCF. We can take a 7x. That leaves x minus 2. Your denominator is a difference of squares. X plus 2, x minus 2. And we did get something to reduce this time. The x minus 2 will divide out. So that leaves us 7x over x plus 2. For our next complex fraction, our first job is to find the LCD. In the denominators, we have x's and y's. In each one, we only have one x, so we will need one x. And in each one, we only have one y. So we will need xy for the LCD. So we'll put that up here and beside each of the ones in this big denominator. Right, now we'll clean up. On that numerator, this is gone. So we have left 16x squared minus y squared. In this denominator, the y will cancel. We have 4x. In the second fraction, the x will cancel, so we have minus y. We need to see if this will reduce, so we factor. The numerator, we can do difference of squares. So we can do 4x plus y times 4x minus y. The denominator, there's nothing you can do. The exponent is 1 and there's no GCF. We did get something that will divide out though. The 4x minus y will divide out. So we are left just with 4x plus y. In our next complex fraction, we look for our LCD. We check our denominators. So we have an a, a 2, and another a. So we're going to need 1, 2, and only one a because the most in any one fraction is 1. So 2a, multiply it by each term. And then we're going to clean up. For the first term, nothing cancels. Gives us 10a. For the second term, that a cancels. So get plus 4. In the denominator, the first fraction, we can divide out the 2, so we get 3a. And in the second fraction, we can divide out the a, so we get a plus 2. We could do a little bit of factoring in the numerator. We have a GCF of 2, so we could take it out. Would leave us 5a plus 2. There's nothing you could do in the denominator. There is no GCF, and your exponent is 1. This will not reduce, so either answer would be correct. This next one is going to be a little bit tricky. Right, so our first job is to find our common denominators. First of all, for the monomial, we will need an x. Right, and for the other terms, x minus 3 and 3 minus x, those are opposites. For a common denominator, you can use either one of those. So let's go ahead and use the x minus 3. Right, and so that's our LCD to multiply by each term. So we have x times x minus 3, x times x minus 3. Right, and the first fraction is the most complicated one to clean up, but you just have to remember that x minus 3 over 3 minus x, that gives you a -1. We did several of those when we worked on that section of simplifying. They are called, they're opposites or negative identicals, right? But we can divide them out and it's equal to a -1. Right, so we have x times -1 times 4 will be -4x. On the second fraction, the x minus 3 goes out. We are left with 5x. On the denominator, the x will go out. The 5 will need to distribute. So we will have 5x minus 15. And in the second fraction, the x minus 3 will go out, so we have plus 4x. All right, let's clean up. So on the numerator, that gives us just 1x. Denominator, 5x plus 4x can go together to give us 9x minus 15. We could factor a little bit on the denominator. It's not going to give us anything to divide out, but we can do it to see possibilities for the answer. We could take out a 3, and that would leave 3x minus 5. But nothing reduces, so either of the last two answers would be correct, either one of these two. This will be our last problem. On this one, we will have to factor the denominator on this bottom fraction to figure out what the LCD will be. But it's a nice trinomial. So we can do our parentheses like signs both plus, split the x's, and how about 5 times 2? Right, so our LCD is going to be an x plus 2 and an x plus 5. Those are all the types of factors that we have, and in any one fraction, they only occur one time. Right, I'm going to erase from down here. And we have to multiply by both of those. So I need an x plus 5 and an x plus 2. Right, and now we'll clean up. We'll go ahead and just do this denominator. Remember, I just factored that, and it is equal to both of these. On the numerators, the x plus 2 goes out. The 6 will need to distribute. So I'm going to come down here just because I'm a little worried about space. So I have 6x plus 30. On the second fraction, the x plus 5 will go out. My 4 needs to distribute. So I have 4x plus 8. And in the denominator, I have left 5x plus 19. So we'll put like terms together. Gives us 10x plus 38. Over 5x plus 19. You can take out a 2 on the numerator as a GCF, and that leaves us 5x plus 19. And so the 5x plus 19 will divide out. The simplified answer is 2.